All right, folks. So this is the extra problem from the packet that we didn't finish in class. So hopefully you've had a chance to think about it and solve it on your own. So I'll work through it step by step here. We're given this equation, this PDE for the unknown variable z. So to solve this, we need to integrate first in x, again in x, and finally in y to undo all the derivatives one by one. So I'll start by just taking the x antiderivative, both sides. So on the left, I'm left with z, y, x, plus, now the 18x y squared, to take an antiderivative with respect to x, I treat y and the 18y squared as a constant. So the x power will become a 2, divide by 2. So this 18 becomes a 9, right? Y squared. So this is the antiderivative with respect to x. Again, treating the y squared as a constant. Antiderivative of the sine, 2x minus y. So I'm going to need a 1/2 to account for the 2x, and then cosine of 2x minus y. And now I have a minus here, right? Because the antiderivative of sine is minus cosine. Of course, you know, if you want to be a little bit more careful here, you could do a u sub, making the u the 2x minus y to be sure. This is all equal to the antiderivative of 0 should be a constant. But of course, because I want to account for the fact that my constant might be a function of y, I'll say this is some unknown function f of y. Okay. So to continue, I'll take another x derivative. Oh, sorry, antiderivative. So partially integrate with respect to x again. On the left, I've undone the x derivative. I'm left with just z sub y plus, so now I need an x antiderivative again, 9x squared, y squared, treat the y squared as a constant. 9x squared will become 3x cubed, y squared, minus 1/4 sine of 2x minus y. Again, doing the sort of the same u sub trick here as I did the last step. So cosine becomes a sine. Don't add another minus sign here, right? And this should equal, now the antiderivative of f of y, well, I need to account for the x that could have been multiplied by this, right? So the antiderivative of a constant is a constant times x, right? So this is that constant times x plus, I need another arbitrary constant, again, another arbitrary function of y in this case. Okay. And I'm just about done. Now all I need to do is take another antiderivative, this time with respect to y. So integrate everything, dy as a final step. Okay, so z sub y, well, that just becomes z, my unknown, that's good, plus antiderivative here, treat the x cubed as a constant, 3y squared, well, antiderivative there will be y cubed. And now I need an antiderivative of the sine 2x minus y. So I'm going to be a little careful here. There's a lot of minus signs flying around here. So this is going to go to a minus cosine. So this is now a plus, but I need another minus coming from the minus y if I did a u sub. So I think overall I get a minus again. Okay. I guess to be really safe, you should do a u sub here, just to be really careful. But this equals, okay, antiderivative of f of y times x. Again, think of the x here as a constant since I'm integrating with respect to y. So I just have x times the integral f of y, but that's just another arbitrary function. So I'm going to call that x f of y plus antiderivative of g of y. Well, again, that's just another arbitrary function of y. I'll rename it g of y. Plus, now I need a plus c. My arbitrary constant in this case is a function of x. So So I'll call it h of x. And I think I'm there. So if I wanted to solve explicitly for the function z, I just need to, rearrange my equation. I'll get 1/4 cosine of 2x minus y minus x cubed y cubed, and then all my stuff on the right hand side. So x y plus g of y plus h of x, where f, g, and h are all arbitrary. Okay. So hopefully you're able to do this one successfully. It's repeating a lot of the same ideas we've seen in class, just being a little careful about what is an arbitrary constant, right, at each step. Okay, if you have questions, let me know, but hopefully this was helpful. Okay.